Welcome to our lecture series on statistics. Today we'll be dealing with the mean as a measure of central tendency. The measure of central tendency is a set of descriptive statistics that tends to establish a typical value or a central point of an entire data set. There are various types of measure of central tendency, which include the mean, the median, and the mode. However, the mean is the most widely used measure of central tendency because it justifies the measure of central tendency than other measure of central tendency. Another reason is because it includes the entire data set when determining the central location of the data set, unlike the median, which focuses more on the middle value when the value is arranged in ascending order or in descending order. The mode also is not too good as a measure of central tendency because it only targets the values that appears the most or the highest value within the data set. There are various types of means. We have the arithmetic mean, which is denoted by x bar, and the formula to compute it is summation of the product of frequency and observations divided by the summation of the frequency. This formula is applied only when the data set is grouped. However, if the data set is not grouped, then the formula to compute the arithmetic mean is summation of the observation divided by the number of observations. The arithmetic mean is widely used more than other means, like the harmonic mean. We have also the harmonic mean, which is being computed using this formula and denoted by h. That is number of observation divided by the summation of the reciprocal of the observation when it is ungrouped. But when it is grouped, then you use the summation of the frequency divided by the summation of the reciprocal of the frequency, that is frequency divided by the observations. We also have the geometric mean. The geometric mean is also another kind of mean which is mostly used in the other kind of statistical studies. One thing about the arithmetic mean is that it is widely used more than the other means, and mostly it appears only as mean. So without this adjective arithmetic, whenever you see mean, we are talking about the arithmetic mean. The arithmetic mean is the mathematical average of the entire data set, and it is a good representative of the entire data set because it includes the entire data set in determining the central focus or the central location of the data set entirely. However, one thing about the mean is that you cannot use it when your data is nominal or ordinal data. But however, if your data is interval or ratio data, you can use the arithmetic mean to determine the central position of the data set. In nominal or ordinal data, mostly it is preferable you use the frequency and percentage to calculate to describe the entire data set. But for ordinal and for interval and ratio data, it is preferable we use the mean, either the geometric mean or the harmonic mean or even the weighted mean. It's another type of mean itself. Another problem of the arithmetic mean is that it is very sensitive to outliers, very, very sensitive to outliers. Outliers are extreme values that tends to have distance away from the other data within the entire data set. So if you have a data that is skewly distributed, computing the mean, those outliers will tend to pull the mean away from the central position, thereby disfavoring the other data which are very small. And if you have also other extreme values which are very low and you have more of the values which are very below, it will also dislodge the mean away from the central position. So one of the problems of arithmetic mean is that it is very sensitive to outliers. When a data is skewed, computing the mean means that we have to transform the data itself. We transform the data itself to become a log scale data so that it will be normally distributed. So the harmonic mean is another type of mean. It is the reciprocal of the arithmetic mean divided by the reciprocal of the observations. And it is applicable when the reciprocal of your data set is more important, is more useful than the real data itself. The average of groups with different sample size are better computed using the harmonic mean. One thing about the harmonic mean is that it is sensitive to difference in number that contribute in number of size, that is the sample size that contributed to a mean. So if you have different sample size where you obtain data from, it is preferable you use the harmonic mean so that it will justify the central location of the means you are trying to compute. Now, the geometric mean is the type of mean that uses the nth root of the product of the observations, and it is very sensitive to outliers. Very sensitive to outliers in the sense that you transform the data to be normally distributed by transforming the data to become log data. So once those data are being in logarithm form, it is easier to compute the mean and determine the central position of the mean. So when data are obtained from a log scale data, the geometric mean is more suitable to determine the central position of the mean. And the geometric mean is mostly applicable in the serological studies or in the microbiology, in microbial growth determination. These are areas where geometric mean are very good in application. Unlike the harmonic mean are suitable to apply in areas like simple pendulum, compound pendulum, and maybe projectiles, verification of Ohm's law. These are areas where the harmonic mean can also be applied. Now let's compare the mean or the mean of data. In this data here, we can see the data here, there are 10 in number, and we can see the mean, the geometric mean, and the harmonic mean. The mean here stands for the arithmetic mean. So we can see the values, how they varies from one to the other, and they are all computed from these values. So the variation of these values here, of these mean values here, are just very little. However, this variation can increase with an increase in the size of the data sets. So now, how do we interpret our mean when we compute our mean from our entire data set? However, to interpret the mean, practically it is better we go pari passu with other descriptive statistics, because determining your central location of your entire data set doesn't mean anything. It's just a summary statistics. We have summarized the whole bulk of data just to be one. Unlike in this data here, you see where there are 10 in number, but we have summarized it to become just a single value representing the entire data set. So, but how do we now interpret that mean? The mean doesn't mean anything because we will only just summarize the data so that it will be useful. However, in order to practically to interpret our mean, it is better we go pari passu with other descriptive statistics like the standard error of mean, like the standard deviation, like the skewness and kurtosis. So these are other descriptive statistics that we can use to in pari passu with our arithmetic mean or geometric mean or the harmonic mean or even the weighted mean, so as to be able to describe our entire data set. So I hope you enjoyed this lecture. If you enjoyed it, make sure you give us your comments below so that it can help us to improve our video in our next lecture. In our next lesson, we will be dealing with the standard error of mean and also as well as the standard deviation, and subsequently as skewness and kurtosis. Thank you very much for listening. Have a wonderful day. Thank you.